we're going to continue talking about collisions. So again, we're going to look at two objects. We're going to start with object A. But now, instead of it being like a hard block, we're going to imagine that it's a rubber ball. And so it's moving to the right at some initial velocity. Now, we're going to look at the same collision as before, but now we're going to pretend that B is invisible. So we're just going to look at A right now and see what happens to A. So as you can imagine, just after they impact, since it's a rubber ball, it's going to start to, change its shape a little bit. It's going to be a little bit more compressed. And then it's going to be experiencing a push against it. This is just after the collision. And so that push, like we talked about before, is actually A delivering some of its momentum to B, or it's giving away some of its impulse. So because of that, the velocity of A is going to start to slow down. A little while later into the collision, A is going to be feeling an even bigger force against it as it continues to try and push B, and that's going to slow its velocity down even more. But then eventually, B is going to have sped up enough that A is going to start to get its original shape back. It's going to be because it's going to be feeling less of a push from B. And then finally, after the collision, A is just moving with this small, velocity, where we notice that its initial velocity is much larger than its final velocity. Okay. Now let's look at the B side of things. So B was moving to the right, but much slower than A initially was, because A eventually came and caught up to it. But the same thing happens during the collision. B gets smushed because now it's feeling a small push to the right, so its velocity starts to increase. As A pushes against it more, its velocity continues to increase even more. But then its velocity, since it's moving faster than A, it starts to regain its shape again. It's pushing off. It's feeling less of a push from A, until finally, after the collision, B's back to its original shape. But now it's moving much faster. So now B started out with this smaller velocity and ended with a much larger one, right? And we talked about what's happening. A's giving some of its momentum to B. And we said that the amount of that momentum is its impulse. But so what's this push that A's feeling? A's feeling this push back against it from B. And similarly, B is feeling a push from A. This push is what we call the force. So a force is just a push. It's something that's changing the momentum. So technically speaking, the force is the impulse over time. So if we look at just one small instant where the change in impulse is constant, then we're saying that whatever impulse was changed during that small amount of time is the force. In other words, force is the rate at which momentum is changed. Or we could also write this as impulse is a force times the time that force is being applied. In other words, the force applied over a time is what's changing the momentum. Okay? But let's look at what this tells us. We know from what we talked about before that the amount of that the impulse that A loses is exactly the same as the impulse that B gains. Furthermore, we know that the time that the collision took place is exactly the same for A and B. It's the same collision. So the time that A was colliding with B is the same exact time that B was colliding with A. We know that intuitively. But now let's look at what this means. This means that the force of A on B is exactly the same magnitude, but in the opposite direction of the force from B on A. Okay? This is actually Newton's third law. So this is something that in the next book, when we start talking about Newton's laws, we're going to talk a lot more about forces, and we're going to talk about what this means. But we see it, making its first appearance here. What Newton's third law is really telling us is that during any collision, the forces balance out. They're in equal and opposite directions. So the force on A is the same, as the force from B coming on to A. Okay. The only other thing that we'll mention about force is the units. Okay. The units, we actually just call force, we give its own unit. It's so important. And that unit is the Newton. And N is how we represent that. So 1 Newton is equal to 1 kilogram meter per second squared. So we notice that we write kilogram, and this is the unit that we've been giving to mass so far. So in the next video, we're going to actually talk about mass a little bit and what mass is. If you remember in the first video in this section, we talked about how mass and weight are different, because weight is actually a force, which is a vector, while mass is a scalar. So we're going to explain in detail, what that means in the next video.